Okay, this section is section 6.4, properties of rhombuses, rectangles, and squares. So we talked already about all the properties of a parallelogram, and so all of these new figures that we're talking about now are all parallelograms. So all the properties we just talked about in section 6.2, all of those properties apply for rhombuses, rectangles, and squares, but now we're going to add some new additional properties that make them specifically these different shapes. Okay, so a rhombus is a parallelogram with 4 congruent sides, and the theorem that goes along with this says that if a parallelogram is a rhombus, then its diagonals are perpendicular. Okay, so that's what it's showing here. If it's a rhombus, meaning it's a parallelogram. Now they're not showing me that it's a parallelogram, but they told me up here that it is a parallelogram, so they don't need to show me all of that on the picture as well. So I know it's a parallelogram and I know it has 4 congruent sides, so therefore another thing I know about a rhombus is the diagonals must be perpendicular. And again, what we mean by that is it forms right angles. And again, if these diagonals are perpendicular, if that's a right angle, then I know that all 4 of these are right angles. So if it's helpful to you to fill all 4 in, that might be, a good thing for you to do. Anytime you see diagonals and you know that it's a rhombus, you can go ahead and stick all 4 of those right angles in, and that might be helpful for you. Another thing it's saying here is that if a parallelogram is a rhombus, then its diagonals bisect a pair of opposite angles. We talked about bisect again in section 6.2. We said it means cuts in half. So again, the diagonals are cutting the angles in half. So again, I already know it's a parallelogram. It's telling me that. Okay, I know opposite sides are parallel and all the properties from section 6.2 apply. And if it's a rhombus, meaning all 4 sides are congruent, another thing I know about it is that the diagonals bisect the opposite angles, meaning cut them in half. Okay, so it's showing me that this diagonal's cutting this angle in half, which means these 2 are congruent, and this diagonal's cutting this angle in half, which means these 2 are congruent. Okay, but I also already know from a parallelogram that opposite angles are congruent to each other. So that technically means that all 4 of these little guys have to be congruent to each other. Okay, same applies over here. I know this diagonal is bisecting this whole angle, which means these 2 are congruent. I know this diagonal is bisecting this whole angle, which means these 2 are congruent. But since opposite angles are congruent, I therefore know that all 4 of these angles must be congruent to each other. Okay, so that's some properties for a rhombus. So let me let you see that. I'm going to go and get that cleared and move up, and we'll look at the next thing about a rectangle. Okay, so for a rectangle, it says a rectangle is a parallelogram with 4 right angles. Very well there. Okay, a rectangle is a parallelogram with 4 right angles. So again, parallelogram meaning all the properties about a parallelogram we learned in section 6.2 apply to a rectangle. An additional thing about a rectangle is that it has 4 right angles. And then now something new we're learning is that if a parallelogram is a rectangle, then its diagonals are congruent. Okay, so again, I see my 4 right angles, and they went ahead and drew in the diagonals, and now they're telling me that if I know for sure it's a rectangle, then I know for sure that those diagonals must be congruent to each other. Again, they're showing AC is congruent to BD. Okay, now for a square is a parallelogram with 4 congruent sides and 4 right angles, which, this is the definition. It's a parallelogram, first of all the properties from section 6.2 apply. This is saying the same thing it did for a rhombus. This is saying the same definition it said for a rectangle. So for a square, it basically has all the properties of a rhombus, all the properties of a rectangle, and of course all the properties of a parallelogram. It doesn't have any new properties, but it's just kind of a combination of all of those. Okay? So I'm going to go and move this up, and then it'll kind of show you a good summary of all of that. Okay, So if we look at this summary, if we go and write down what the rhombus properties are, then I first want to include for a rhombus that a rhombus is a parallelogram. Okay, so I'm not going to write all the properties that we just talked about. I think there were 4 different properties we talked about in section 6.2 about a parallelogram. All those apply. I'm just going to say it's a parallelogram. I know all those are true. One of the new things we said about a rhombus is we said that it has 4 congruent sides. Okay. Another thing we said about a rhombus is the diagonals are perpendicular. I'm just going to use my upside down T to represent perpendicular. And the additional thing we said about a rhombus is the diagonals bisect the opposite angles. So diagonals bisect, I'm just going to abbreviate opposite angles. I'm going to abbreviate angles just to shorten it a little bit. Okay, for a rectangle, the things that we just said were that all the parallelogram properties apply. Okay, and we also said that a rectangle has 4 right angles. Okay, and then we also said the diagonals are congruent. Okay, and then for a square, we said rhombus and rectangle properties combined. Okay, so, you know, again, a square has no new properties on its own, but it has all of the properties that are listed right here. Okay, for time's sake, I'm just going to list all properties listed above. Okay, if you find it's helpful to you to write down all of those in this spot just so you can see that, that is fine. Take the time to do that. That might be helpful for you. Okay, and then this is also something that helps people. This is a Venn diagram. I'm sure you've heard of Venn diagrams before, but this I think helps someone that the words is just too much for them, but sometimes visually it helps people understand a little bit. The big box here is showing parallelograms. So it's showing you that all of these things are always parallelograms. Okay, but then more specifically here, I can see that the rhombus oval and the rectangle oval overlap, and where they overlap is, it says square. Okay, so what this is telling me is that a square is always a rhombus because it's in that rhombus oval, but a square is also always a rectangle because it's in that oval. It has all the properties of both. If I'm right here though, you know, this is a rhombus that is not a square and it's not a rectangle. It doesn't have those properties, it just has the rhombus properties. Okay, if I'm right here, it's a figure that could be a rectangle. It's definitely a parallelogram, but it's not a square and it's not a rhombus. Okay, so sometimes that helps people to visualize that. All right, so now if we start solving using some of these things, let's look here at example 1. Okay, so on 1, it says find the measures of the numbers of angles in each rhombus. So here, remember what we just said about a rhombus is that we know that all of these 4 angles must be congruent to each other. So if I can figure out one, I can figure out all the rest of them. Okay, and then remember back to a parallelogram is that consecutive angles are supplementary. So I know that this angle plus this whole angle has to add up to 180. So if I go 180 minus 106, then I get 74. Okay, so I know that this whole angle from here to here is 74. Well, I guess I can show that here. But if I want to know what each one of these separately is, I can go 74 divided by 2, which gives me 37. Okay, and I can go ahead and get that filled in right here. All right, and if I know that these two are 37, then I know that these two are 37 also. okay? Again, if it helps you to list those off to the side, that's fine as well. I think this and the pictures are big enough that you can kind of see my answers there. Okay. Actually, maybe I'll go ahead and list them. A measure angle 1 is 37, just to make sure it's clear. 2 is 37. 3 is 37. And 4 is 37. Okay, if we move on to the next one, I'll switch colors for the new problem. I can see that this angle is 26, okay? And so again, just like we just said a second ago, I know that all 4 of these angles must be congruent to each other. So if this one is 26, I know that one's 26, I know that one's 26, and I know that one's 26. So that helps me answer the fact that measure of angle 1 is equal to 26 degrees. Okay, now I can see that this is a triangle, and those 3 angles have to add up to 180, and I know 2 of the angles. So I can use that triangle angle sum theorem to add these up and subtract 180 to get angle 2. So I can say measure of angle 2 plus 26 plus 26 is equal to 180, and plus 52. So measure of angle 2 plus 52 is equal to 180. And when I solve for measure of angle 2, then I get 128. Okay, so that's angle 2, and then based on it being a parallelogram, I know opposite angles are congruent. So this also has to be 128. Now I'm going to lift these off to the side again just so you can see them well. Measure of angle 2 must be 128, and measure of angle writing too fast. Here we go. Measure of angle 3 is also 128. Okay, so that gives us those angles. Now if we look down here at number 3, again, you don't have to go in order from 1 to 4. You know, right when I glance at this, I can see opposite angles are congruent. If that's 113, that must be 113. Okay. I also know from here that I know that these 4 angles must be congruent to each other, okay? Because again, if it's a rhombus, the diagonals bisect the opposite angles, okay? And I know that if this is 113 and these 2 are congruent to each other and they all add up to 180 based on the triangle angle sum theorem, I could say call both of these x. I could say x plus 113 is equal to 180. So that would give me 2x plus 113 is equal to 180. So that would give me 2x is equal to 67. And if I solve for that, I get x is equal to 33.5. Okay, so that helps me solve here that measure angle 1 is 33.5. Measure of angle 2 is 33.5, and that's also telling me that angle 4 is 33.5. And again, if it helps you to list those off to the side to help make it more clear, that is fine. 1 is 33.5. Measure of angle 2 is 33.5. Measure of angle 3, we said was 113, and measure of angle 4, we said was 33.5. Okay, so again, use the picture of fill in. As you find angles, fill it in, and that might help you find the next thing. All right, here, next one is 4. When I look at this one, the first thing I see is 2 diagonals. Anytime it's a rhombus and I see those 2 diagonals, I'm automatically going to stick my right angle symbols here in the middle. Okay, so that tells me over here that I know that angle 2 has to be 90 degrees. Okay? The next thing that I see right off is the fact that, again, if it's a rhombus, the diagonals bisect the opposite angles, which means all 4 of these angles must be congruent. You know, I know that this angle, this angle, this angle, and this angle all are congruent, and if that one's 58, that means they're all 58. So that means that angle 3 must be 58, you know, that's 58, that's 58, that's 58. So I can go ahead and show that measure of angle 3 is equal to 58. Okay, and then I can look over here to see that this is a triangle. If that's a triangle, and I know 2 angles, and I want to find the 3rd angle, again, I can use that triangle angle sum theorem to find this missing angle here. I can use the fact that measure of angle 1 plus 90, because I know that's 90, plus 58 has to equal 180. Okay, so if I do that and solve, I end up with measure of angle 1 being 32. Okay, so I can get that filled in my picture, and I can fill that in over here. And then remember what we talked about again, diagonals of a rhombus bisect the opposite angles. That means that all 4 of these angles must be congruent. Show that with a different color. You know, I know that this angle, this angle, this angle, and this angle must all be congruent. So if that one's 32, this one must also be 32. So I know that over here, measure of angle 4 must be 32 degrees. Okay? All right, so I'll give you a second to get that. Pause it if you need to still get something down. And we'll keep going. All right, let me get that moved up. Okay, now if we look at example 5, this one says quadrilateral MNOP is a rectangle. It's telling me MO, the measure of MO, remember no line on top, measure of MO is 6x plus 14. I think it's helpful just to label your picture when possible. So here is 6x plus 14. And they're telling me that PN is 9x plus 5. And they want to figure out what x is. So those are the diagonals of a rectangle. I have to remember one of the properties we learned about a rectangle is the diagonals are congruent. So as long as I remember that, I can just set those equal to each other. And that one ends up being pretty quick and easy to solve. Okay, if I go and solve that, I can subtract 6x from both sides to get 14 is equal to 3x plus 5. I go ahead and subtract 5 from both sides, I end up with 9 is equal to 3x, and if I go ahead and solve from there, I get x is equal to 3. Okay, and that's all it's asking for. Sometimes they might ask you to plug back in to find something else. In this case, they just ask you to solve for x. If we look down here, it tells you again ABCD is a rectangle. Just make sure you're looking for those keywords. They're giving some hints of what to do. Just find x and y. So I have to try and think in this case of 2 true equations to solve for x and y. So if I think about what I know about a rectangle, one thing that I know is that all these angles are supposed to be right angles. That helps you to draw that in the picture. So if that's a right angle, and I know the expressions for those 2 angles, I know those 2 angles must add up to 90. So I can say 9x plus 20 plus 4x plus 5 equals 90. Okay, I know you can solve that from there. And then I need to think about what other true equation I can write. And in this case, I can see that, well, if it's a rectangle, I know that these sides are parallel. And I know this is my transversal, so I therefore know that these 2 angles must be alternate interior angles that are congruent, so I can set those 2 equal to each other. So 6y minus 20 is equal to 4y plus 4. Okay, so if you want to pause this and go ahead and solve this out yourself, and then check your answers with mine, you know, that would be good practice for you. I'll go ahead and solve it from here, and I can go ahead and say 13x plus 25 is equal to 90. From there, I've got 13x is equal to 65. And from there, I end up with x is equal to 5. Okay, solving for y. I end up with 2y minus 20 is equal to 4. From there, I've got 2y is equal to 24. And when I solve, I've got y is equal to 12. Again, pay attention what they're asking for. This time they're just asking for x and y, so we're good at that point. Okay? All right, let's go ahead and get that cleared. And keep on going. Okay, on 7 through 10, this is asking us to determine the most precise name for each quadrilateral. Sometimes they're going to ask you to name all that apply, and you're just trying to think through which ones apply. This time, though, they're just saying what's the most precise name, which is just one answer. So in this particular case, if I can see the opposite sides are parallel, I know it's a parallelogram. But if I see all 4 sides are congruent, then more specifically than that, I know it must be a rhombus. You might say, oh, well, squares have all 4 sides congruent. That's true, but a square would have to have right angles here in the corner, or congruent diagonals, something that's letting me know it's a rectangle, and therefore, if it's a rhombus and a rectangle, then I would know it's a square. But at this point, the most specific thing I know is a rhombus. Okay, next one, I know that opposite sides are parallel based on the arrows. I know opposite sides are congruent, which is also a parallelogram property, okay, but there's nothing that tells me that it's a rhombus. I don't see all 4 sides congruent, I don't see perpendicular diagonals, that kind of thing. I don't see right angles in the corner, so it's not a rectangle, and if it's not a rhombus and a rectangle, it can't be a square, so the most specific thing I can say here is parallelogram. I can't talk and spell parallelogram at the same time. So there we go, parallelogram. Then next one, I can see opposite sides are parallel, so I know it's a parallelogram. But now they didn't mark the sides congruent, but they're telling me they're all 7, so therefore I know they're all congruent. Again, there's nothing telling me that it's a rectangle. I don't see congruent diagonals, I don't see right angles in the corner. It's not a rectangle, it can't be a square. So the most specific thing I've got here is rhombus. Okay, and then last one, I can see it's parallelogram, opposite sides are parallel. I don't see the fact that all 4 sides are congruent or the diagonals are perpendicular to make it a rhombus, so I'm ruling rhombus out. But I do see these 90-degree angles, right angles in the corner, and that's enough to tell me that it's a rectangle. It can't be a square though, because I didn't say it was a rhombus. So rectangle is the most specific thing here. Okay? On number 11, now this question is a little different than this one. This one asked for the most precise name, so we're naming one answer. This one is asking us to list all that apply, the quadrilaterals that have the given property, choose among parallelogram, rhombus, rectangle, and square. The way we're going to do this is for parallelogram, instead of writing all these words out, we're going to use a P. For rhombus, we're going to use an RH. For rectangle, we'll just use an R. And for square, we'll use an S. That'll just make it a little quicker. So you're gonna, some of them may have all 4 letters, some might have 1, some might have 2. You know, again, this is one, if you want to go through and try it first, you know, that might be helpful to you. And then you can check with my answers, but if you want to go through it with me, that is fine. We'll try to go through these pretty quickly, just since there's lots of them. And again, I just got to think about the different properties. And we're going to fill something in on the next page that might help you visualize this in a different way. So when it says all sides are congruent, the first thing I want to think about is if it's a property of a parallelogram that we mentioned on the section 6.2 day, if I put P, it also is therefore a property of rectangle, rhombus, and square also, because they are parallelograms. So all sides are congruent. That is something we said for a rhombus. And if it fits for a rhombus, then it also applies to a square, because a square has all the properties of a rhombus. Opposite sides are parallel is a parallelogram property. So if I put P for parallelogram, I therefore know it's going to fit rhombus, rectangle, and square as well. All angles are right angles. Okay, that's one of the properties of a rectangle. And again, because a square has all the properties of a rectangle, it fits square as well. Diagonals bisect each other. That's a property of a parallelogram. If it's a property of parallelogram, it fits the other three because they are parallelograms. So rhombus, rectangle, and square as well. Diagonals are perpendicular. That's one of the specific things we said about a rhombus. And again, if it's a property of a rhombus, it's automatically a property of the square also, because the square has all the properties of a rhombus and a rectangle. Okay, opposite sides are congruent. That is one of the properties we said of a parallelogram in section 6.2, so therefore it applies to all of them. Opposite angles are congruent. Again, property of a parallelogram that we said in section 6.2, so it therefore fits all of them. And last one you can see here, there are a few more that I'll move up in a second, but consecutive angles are supplementary. That's a property of a parallelogram, and so therefore it fits the others as well, rhombus, rectangle, and square. Okay, let me get that cleared and moved up here. So the last two that we haven't done yet are diagonals are congruent, and that is one of the properties we said of a rectangle. Again, if it fits for a rectangle, it automatically fits a square as well, because the square has all the properties of a rectangle and rhombus. And each diagonal bisects opposite angles. That's one of the properties we said about a, ooh, that didn't turn out very well. Try that again. So that's one of the properties we said about a rhombus. And if it fits for a rhombus, it automatically fits for a square as well, since a square has all the properties of rectangle and rhombus. Okay, so that's just a good practice type thing. But again, pay attention to the question. If it's asking for the most precise one, means one answer. If it asks for list all that apply, you'd be listing or checking all that apply. All right, the last little bit here is the summary of the quadrilaterals. So, move it up a tad bit so you can see this part. So, this is saying, this is just another good visual to kind of put all of this information together. So, the very top box is going to put, you're going to put the word quadrilateral. It's written right above the box for you, but you're going to go and fill it in here. All of these shapes we're talking about are quadrilaterals. Okay, and a quadrilateral is a four-sided figure, a four-sided polygon. Okay, one type of quadrilateral that we've been talking about has been a parallelogram. Okay, there are other quadrilaterals that are not parallelograms, and we're going to talk about some of those in section 6.6. But then all of this are things that we have said about a parallelogram. Okay, we said opposite sides are parallel, obviously, hence the name. Okay, we've said opposite sides are congruent. I'm just going to put the congruent symbol. Opposite angles are congruent. I'm just going to do the congruent symbol. Consecutive angles are supplementary. Diagonals bisect each other. Remember, cut each other in half. Okay, so diagonals bisect each other. And the last one, it says one pair of opposite sides is both parallel and congruent. It's okay if that one doesn't seem familiar to you. That is actually something from section 6.3 that we chose not to cover with you at this point. So you don't necessarily need to worry about that one right now, but all of these others we have talked about. Okay, so let me go ahead and move it up, and then we can see how rectangle, rhombus, and square fall in line with this as well. Okay, so if you kind of see, we had parallelogram, and then branching from parallelogram becomes two shapes here. So this is talking about four right something and then four side something. So I have to kind of use the key things here to help figure out which one goes in which spot. But I know if we're talking about 4 right angles, we're going to talk about rectangle here. Okay, and if we're talking about sides being congruent, we're going to put a rhombus here. Okay, and again, definition of rectangle we said is there's 4 right angles, and we said diagonals are congruent. You just use the congruent symbol. For a rhombus, we said 4 sides are congruent, and the diagonals are perpendicular. You can use your upside down T, or if you want to write the word, you can. And then the other thing we said about a diagonal is they bisect a pair of opposite angles. Diagonals bisect pair of opposite, just abbreviating opposite, and angles. Okay, so bisect a pair of opposite angles, and then from there, rectangle and rhombus funnel down to a square. And again, a square has no new properties, but it has all the properties listed above on this page. Because a square always has the properties of a rectangle, it always has the properties of a rhombus, and it always has the properties of a parallelogram. Okay, a rectangle has all the properties of what's above it, always has the properties of a parallelogram, but it just sometimes has the properties of a, it's sometimes a rhombus, it's sometimes a square, but it's always a parallelogram. Same thing with a rhombus. It's always a parallelogram. It has all the properties of a parallelogram always. Sometimes it's a rectangle, sometimes it's also a square. Again, it's sometimes these visuals just kind of help with that a little bit. If you have any questions, just let us know, and we'd be glad to help you out.